This is Office Hours at Duke University. Today's conversation is with Bill Shamitas. Professor Shamitas is Dean of Duke's Nicholas School of the Environment. He is a member of the National Academy of Sciences and was chief scientist at the Environmental Defense Fund before coming to Duke. His blog is called The Green Grok. His explanations of environmental issues appear regularly in news media, including the Wall Street Journal, USA Today, and the Huffington Post. Viewers can join this Duke Office Hours conversation in three ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Professor Shamitas, we're at your office hours, and there's something that you've been blogging about quite a bit recently, the American Clean Energy and Security Act of 2009. This, of course, is the major energy bill that the House passed this summer, and with Congress returning to work next week, it will likely re-enter public debate soon. So remind us, what is this Waxman-Markey bill?
Thank you. At first, let me say to everybody out there in the ether, welcome to my office. It's great to talk about climate. We spent the whole summer focusing on healthcare, which is really, really important. But there's this other important issue that Congress is dealing with, which is climate change. And it's important that we get back and focus on that as well. So there's this bill, we call it Waxman-Markey because it was sponsored by Representatives Waxman and Markey. Historic bill because it's the first time either chamber of Congress, this case the House, passed comprehensive legislation on climate change. So it's a major, major step in getting the American country and economy to begin to focus and deal with this issue. There are a number of aspects of this bill that I can tell you about. First of all, let me tell you that it's 1,200 pages long. It's written in a very arcane, legalistic language. So I've read, a good part of it, and I'll tell you what I understand, but I don't pretend to have memorized every line on those 1,200 pages. So the most important part of this bill is it mandates a decrease of emissions over time. As an environmental scientist, when I look at climate change and I look about what we need to do in terms of policy for climate change, the most important thing that we must do is we must come up with a way to decrease emissions over time. And this bill mandates that happening. It mandates a 20% or so decrease in emissions by the middle of the 2020s and some 83% decrease in emissions by 2050. Not all at once, slowly over time, getting to that level. So that's the major feature of it. That's the important feature of it. That's the part that I really, really like. It does this through something that we call a cap and trade system. It's a market-based system. Rather than the government getting in heavy-handed way and telling everybody what they can do to lower emissions, it simply says the emissions can only be larger than a certain amount. And then the government hands out or auctions, depending upon on the various details of the bill, these emission allowances. All the total of those emission allowances equals the cap in emissions and tells the emitters, the marketplace, figure out how to do it. Those people who can figure out the easiest, most cost-effective way to lower emissions are going to make lots of money. And the good part of that is what it does is it incentivizes the marketplace, the inventors, the entrepreneurs to come up with major innovations to lower emissions. And history shows that that's a very effective and inexpensive way to make innovations, to make transformational changes in technology. Now, the other aspects of the bill, the more detailed aspects of the bill that receive a lot of discussion, is important, has to do with how those emission allowances are given out. Some are given away free, some are auctioned. Over time, the amount that gets auctioned goes up over time. How the market works, what to do about international competition, and the like. But the most important part of it, in my mind, is this decrease in emissions over time.
Very good. Professor Shamitas. Viewers can join this Duke Office Hours conversation in three ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Professor Shamitas, you've just outlined this Waxman-Markey bill. What's your judgment on it? Are you for it? Do you support it?
Let me say that this is not a perfect bill. We have a democratic representative government, and a lot of that system is built on the notion that in order for us to do something, it requires compromise. It requires a significant amount of people or representatives to come together and agree on doing something. And there's absolutely no question that this bill involves a lot of compromises, and some of those compromises I'm not especially happy with. For example, the way it's treating biofuels and land use in terms of giving credit for that for lowering carbon emissions is something that I'm not happy about. But in order to do something, we've got to make some compromises. The other thing is, for me, the most important thing that we can do is we can take this first step that mandates a decrease in emissions over a long period of time and sends a message to the marketplace, to the innovators and the entrepreneurs that I just mentioned, that we're going to have to decrease emissions and you can make a profit by figuring out how to do that. And my hope and belief is that when we put this system in place, those new technologies are going to come on board really, really rapidly, a lot faster than we actually think they're going to happen, and we're going to get to where we need to be.
Now you mentioned.
Let me just finish. So in my mind, on balance, I think we should pass this bill. Now, the bill doesn't get passed until the Senate does its thing, and there's always the possibility that the Senate will make some improvements, and then it'll go into conference and we'll have a better bill. We'll have to wait and see.
Now you're talking about the democratic process here, how a bill becomes a law, and you've been doing a lot of political calculus around this. Who and what are the important factors in this bill succeeding or not? So what needs to add up for this bill to get passed?
Well, the Senate has to pass it. So right now, the Senate is dealing with it in a variety of committees, and various senators are taking positions. The best estimate by the Senate watchers or Congress watchers is that there's about 35 senators that are solidly for the bill. That is another 10 or so, 15 or so that are probably yes. And there's another 20 that are fence sitters, and the rest most likely will be no. In order for us to do anything in the Senate, we need 60 votes to get beyond cloture, unless the Senate adopts sort of the nuclear option, which is to do this through a budget reconciliation, which I don't think they'll do. So you got to get 60 senators. So that means you have to get all of the maybes, and you have to get almost all of the fence sitters. That's a very, very tough get. And depending on who you speak to, they say it can happen or it can't happen. We'll just have to wait and see. I suspect that there are a lot of senators that are maybes, or a lot of senators that are on the fence, simply trying to hold out to get something for their own constituency. And when push comes to shove, they will vote for this bill. The other piece of this puzzle, this equation that has to be resolved, is health care. Right now, the focus for the president, the focus for Congress is on health care. That's the highest priority. I don't necessarily agree that that's the highest priority, but that's the highest priority in Washington. And if this health care debate continues to play itself out over many, many months, what's going to happen is it's possibly the climate bill will be delayed until next year, and then all of a sudden we're in the election cycle, and it could be that this will slip away from us.
Very good. Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. We've got a Twitter question here from Yen JH, who asked to Dean Shamides, how does this bill affect North Carolina?
Good question, Yen. So each state is going to have somewhat of a differentiated impact depending upon how dependent they are on fossil fuels or coal for their electricity, and what kind of industries they have available that can ramp up to compete in what we call a low carbon economy. So North Carolina, is going to have some impacts because we have a lot of coal power here in North Carolina. There's not great opportunities, for example, for wind here, but we have enormous amounts of biomass and forests that can be used for what we call biopower or bioenergy. And the estimates that have come out by the Department of Energy, by EPA, and by others suggest that the impact, for example, on our electricity bill is going to be pretty modest maybe a few $100s a year. And we're not going to see that, for another 10 plus 15 years. So I think that what we're talking about is a very slow transition from a carbon-intensive economy to a low-carbon economy. And even those impacts of, say, $100 or $200 or $300 increase in your electric bill 10 or 15 years from now presume that we're not going to make some major breakthroughs in, for example, renewable energy or capture of carbon from coal-fired power plants that are going to lower those costs significantly.
Very good. Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Dean Chamides, you have just mentioned about the possibility that this bill might get put off for another year because of health care. There's obviously other arguments out there about why this is either not the right bill or the right time. We're in a recession. Healthcare is more important. There are, of course, skeptics about the global warming science itself. What do you say to naysayers around this bill?
Okay, so let's talk about the recession issue first. Good point. We're really hurting economically. How can we stand a bill that's going to raise the price of energy, perhaps depress the economy some more, send us into an even bigger recession or depression? Well, first of all, understand that the bill, Waxman-Markey bill, for example, doesn't really do anything until I think it's 2012 or 2013. Presumably by then we'll be out of the recession. And the impacts on the economy are not felt for many, many years after that. We're talking about really significant changes not occurring until the late teens, the 2020s, the 2030s. Secondly, the economic analyses of the impact of Waxman-Markey are that this is going to have an impact in terms of our gross domestic product of 1%, maybe 2%, at the outside 3%. So a couple of percent on our gross domestic product. Small amount. Think about some of the other things that we spend in terms of fraction of gross domestic product. There's been a lot of discussion on how much of our healthcare is expended on, how much of our gross domestic product is spent on healthcare, how much is spent on defense. Those are hugely larger amounts that affect our economy. So we're really talking about a very, very small impact felt much later on. And there are a lot of people who think and argue that actually forcing the country to go towards a low-carbon economy is going to help us rather than hinder us. There are all these new technologies that are being developed, renewable energy technologies, new solar cells, new wind turbines. There was a time 10 or 15 years ago when the United States was the world's leader in those technologies. We are no longer the world's leader in solar energy technologies. We're no longer the world's leader in wind energy. Of the 10 top wind energy companies in the world, we only have one, and it's no longer, it's down in the bottom 5 rather than the top 5. Of the top 10 solar energy companies in the world, we only have one. Where are those companies located? They're located in Europe and Germany and Scandinavia. They're located in Japan. They're located in China. Why do they have those technologies and we don't? To some extent, I think it's because we haven't taken very seriously this need to go to a low-carbon economy. So it's conceivable that by doing this, in the long term, it's actually going to be better for the economy. Now, let me talk a little bit about the climate skeptics. First of all, understand that we have organizations in this country, like the National Academy of Sciences, composed of the really best scientists around the world, chosen by scientists. The Academy is run by scientists. They have been formed, they were formed by Congress when Lincoln was president to advise the nation on scientific and technical issues. And they say that the science of climate change is certain enough to warrant urgent action by all nations, including the United States. I think most people should be satisfied with that. But also let me point out that we've been studying this problem for well over 100 years. A scientist who won the Nobel Prize in Chemistry in 1903 proposed that increases in carbon dioxide would warm the atmosphere. And over those hundreds of years, we've learned more and more and more. Our technologies and ways of measuring and observing the Earth and the climate has increased many-fold. We have much better computers. And we have found to a very, very large degree of certainty that we know the globe is warming. We know that the emissions that we put into the atmosphere are warming the Earth. And we know almost certainly that a major part of the warming over the last 20 or 30 years has been due to those emissions that we've put into the atmosphere. There is a slight bit of uncertainty. We don't know for 100%. But are we going to allow that small amount of uncertainty to keep us from acting on the large level of probability that this is going to occur? Think about the level of certainty that you require in your everyday lives to make decisions about taking out life insurance, about putting on your seatbelt. Let me give you an example. Imagine you were helping to design an airplane that your children were going to be flying 20 years from now. And the design was such that the engineers told you, when your kids get onto that airplane, there's a 95% chance they'll land safely. But there's a 5% chance they'll crash and die. Would that be good enough for you? Would you say, go ahead and do that airplane? And that's the kind of decision that we have to make right now. We don't know for certain. Nothing in this world is for certain. But we are very, very sure that the consequences could be quite dire. Shouldn't we get started now on trying to forego those consequences? Start slowly, do the obvious things like efficiency, and as the science strengthens and as we see this occurring, we can continue to ratchet down on the emissions. And if, say, 5 or 10 years from now, it turns out that it's not a problem, no harm, no foul. All we did was save money by becoming more efficient and developing new technologies. So I think it's absolutely imperative that we move forward. The other thing, let me say, is that the carbon dioxide that we put into the atmosphere will stay in the atmosphere for thousands of years. Some of the carbon dioxide that was put into the atmosphere with the first Model T is in the atmosphere today. And some of the carbon dioxide that you're going to put into the atmosphere when you drive to work or drive home or whatever it is this evening is going to be in the atmosphere not only for your kids but for your grandkids and your grandkids' kids. That's a tremendous legacy to leave for future generations. Shouldn't we be doing something about it? I think we should.
Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Dean Shimidas, and talking about the climate warming conversation, where does efforts here in the U.S. around Waxman-Markey fit into international negotiations and discussions about climate change?
Great question, important question. So if the U.S. acts alone, obviously this is a global problem. It's not going to cut it. So we need action among all the nations, or at least all the major emitting nations. And this past treaty that's expiring in 2012, the Kyoto Protocol that the United States did not join, had a number of flaws in it, and one of those is that it did not require some of the growing emitters like China and India to participate. And so as we look at the expiration of Kyoto and the need for a new treaty, we've got to have a number of things. We've got to have much larger worldwide participation. We need a long time frame so that we send a long-term signal. That's not going to happen unless the United States is part of it. If the United States, which is by arguably the largest or second largest emitter in the world, and is responsible for something like 25% of the current burden of global warming pollutants in the atmosphere, more than anybody else, is not going to join in, I think it's very unlikely that we're going to see anything significant. By the same token, if China doesn't join, it's not going to work. So we need to come up with a global framework where the United States is part of it and the rest of the world is part of it, including some of the developing countries like China, although they don't need to start immediately, but they need to agree to cap their emissions eventually. I think Waxman-Markey is really important because if we have Waxman-Markey in our pocket, or at least Waxman-Markey passed and having to go into conference in Congress to resolve the differences between the House and the Senate, we send a very, very clear signal to the global community that, well, number one, the United States is serious about this, and we're bringing real stuff to the table, and therefore they should. And secondly, we have a really good bargaining chip. The negotiators can come there and say, look, we can't do any more than this. This is what our Congress said we can do, so you got to work with us. I think one of the problems that happened with the Kyoto Protocol is the United States went to an international conference and the world decided what the United States should do. And then we had to come back and convince Congress and the American people to do that, and it was simply a non-starter. We don't need the world telling us what to do. We can figure out what to do ourselves, thank you very much. We need to be the leader. So I think this Waxman-Markey thing fits into this much larger picture, which is the ultimate problem, which is getting global emissions to come down.
Very good, Dean Chamides. We have a question here on Twitter from NC Beth for Duke, and she asks, how are social scientists working with natural scientists to get the message across?
Great question, NC Beth. I think I've got your name right. So first of all, let me say that, for many, many years, the climate change problem was one that was owned by us natural scientists, the physical scientists, the chemists, the biological scientists. And we were figuring out what would happen in the climate and how it would change. We did okay, but we were very far from solving the problem. And we're never going to solve the problem unless we bring the social scientists in, for a variety of reasons. First of all, the society doesn't live in a vacuum apart from the natural world, and the natural world doesn't live in a vacuum apart from society. And we need to understand that interplay. To develop good solutions to climate change, we need to understand how those two systems, if you will, work together. And to come up with solutions, ultimately, those involve social institutions, society, economics, and so forth. So the social scientists are incredibly important to solving this problem. Part of that is to get people to understand the problem, to buy into the solutions, and to figure out the kinds of incentives that we can put into place to convince people to change their behavior in a way that is rational and good for them and good for the world. So social scientists are working. I can tell you that there is a program which is called the Human Dimensions of Global Change, which is social scientists looking at this and trying to work that out. There are a variety of organizations that are dealing with understanding how institutions work and understanding how the public works and how that interacts with the climate.
Very good. Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Professor Chamides, assuming this Waxman-Markey bill is successful and is passed, isn't there a whole other problem that comes up afterwards, which is how do you set up, monitor, and verify a carbon cap and trade system?
Well, good question. I think we've got this figured out, but it's complicated, so let me explain it. So on the one hand, imagine all of us individuals. We're all carbon dioxide emitters. We drive our cars, we do all this stuff. So you can imagine doing the cap by everybody receiving a little letter in the mail that says you can emit so many tons of CO2 for a year, and it's like a credit card, and every time you went to the gas station, you'd put it into the card and take it out, and when you ran out of your credit card, you couldn't fill your gas tank or something. And it would be an absolute nightmare to verify, to monitor, to administer. And no one is suggesting we do that. What we're talking about is applying the caps, what we call upstream. And the farther you go upstream, the easier it is to do. So imagine applying the caps to the power plants, the carbon dioxide that they emit from the power plants, the petroleum refiners, for example, way upstream. Then it's much easier. First of all, you have very much fewer emitters, and it's extremely easy to monitor how much they're emitting. In terms of a power plant, how much coal they use. I mean, we know how much carbon there is in coal. We simply find out how many tons of coal they burned each year, and we know how much carbon they emitted. And the same thing for petroleum. So we apply the cap upstream, and in the case of carbon dioxide, the verification is rather straightforward because we know this relationship between the fuel, the carbon content, and the amount of CO2 that gets into the atmosphere. A much more complicated verification problem comes about on the international scene. So now imagine we have an international agreement where the United States says it will only emit X, and some other country, for lack of, just as an illustration, China says it will emit Y. And China's doing its own verification and monitoring how much coal it burns and everything, but how do we know that, first of all, that China could even be telling the truth, but just doesn't know how much coal they're using, and how can we verify that? And I can tell you that the scientific community is working very, very hard now to develop instrumentation, for example, satellites that will be able to monitor CO2 concentrations around the globe, and using that information, invert that information and infer how much CO2 is coming from various regions. So we have an independent verification that the cap is actually being held.
Very good. Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Dean Chamides, one word that gets used sometimes in these climate change scenarios is geoengineering, or climate engineering. You're talking about satellites just monitoring, but what about human beings actually interacting with the worldwide climate? What do you think of those scenarios?
So the idea of geoengineering comes about because one might believe or say or conclude that either it's just too hard and too expensive to lower CO2 emissions, or we can't do it fast enough. And the climate is changing too fast. We've got to do something to correct the climate in the face of these emissions. And so what you end up doing is you treat the symptoms rather than the cause. So you figure out a way to counteract the warming effect of CO2 and these other greenhouse gases. So for example, one idea would be that you put little particles up into the atmosphere, into the stratosphere, that reflect light. And by reflecting sunlight back out to space, you effectively cool the Earth and counteract the warming. Or you can do things by changing the chemistry of the ocean that would put more CO2, take more CO2 out of the atmosphere, and a variety of other ideas. So interesting. So there's a couple of issues that one needs to bear in mind that leads me to think that it's a little too early to resort to geoengineering. First of all, it's easy to think about it, but imagine if you wanted to continually put particles up into the stratosphere using airplanes. It turns out that logistically that's a difficult thing to do. Secondly, you're altering the natural system. You're altering, in this case, the atmosphere, to do this, to lower the temperature. But while you're lowering the temperature by reflecting light from the stratosphere, you're decreasing the amount of energy that's absorbed in the stratosphere, that's absorbed in the atmosphere, that's absorbed in the surface of the Earth. As a result of that, you're going to change the atmospheric circulation. As a result of that, you're probably going to change the precipitation patterns. And as a result of that, who knows what. And so what you're doing is you're maybe solving one problem and creating another that is maybe even worse than the first one. So do you really want to take that chance? And the last thing is that simply countering the warming effect of CO2 actually doesn't solve all our problems. For example, in addition to being a warming gas, a heat-trapping gas, carbon dioxide is a weak acid when it dissolves in water or dissolves in seawater. And what's happening is by continually putting CO2 into the atmosphere, we're increasing the acidity of the ocean. And as we increase the acidity of the ocean, we're making it harder and harder for what we call calcareous critters in the ocean, like coral reefs, like shrimp, like clams and things like that, from forming their shells and their skeletons. And ultimately, that has an impact on the entire food chain of the ocean. And more than 1 billion people depend upon that food chain. So simply cooling the atmosphere by, say, putting up a reflective shield into the stratosphere doesn't address the problem of ocean acidification at all. So interesting idea, a great thing for scientists to study and investigate, to try to figure out, and maybe we'll learn more about the climate by looking into it. But I think it's a potentially really dangerous concept to try, and I would say let's leave it on the very, very, very back burner for something to think about maybe decades from now if we need to.
Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. We've got another Twitter question here from Yen JH, who asks, some say legislation is too little too late. what would you do to improve it? So, Dean Shimidas, if you were writing legislation either in Congress or for the UN, what would your bill be?
Thanks, Yen J.H. Isn't that your second question? No fair. Anyway, so what would I do to improve it? Well, there's a number of things that have to do with biofuels and bioenergy that I'm very, very concerned about. When you begin to take land that is basically a forest or in fallow, and you convert that over into some sort of biocrop, and the reason you do that is because you can make a profit by using that biocrop. What ends up happening is that there's this large growing incentive all around the world to cut down forests to grow biocrops. And the problem with that is every time you cut down a forest, you put huge amounts of carbon dioxide into the atmosphere, not only countering the effect of using the biofuels, but actually making it worse. And I think that is a major, major flaw in the Waxman-Markey bill, is to make sure that we do not inadvertently lead to the loss of very, very important forests in the United States and around the world by giving false credit to biofuels and biomass burning is one example.
Dean Shimidas, we have another question. This one comes by email from Joe Ming, who asks, Dear Dean, Dr. Shimidas, we know that ozone has different effects in different parts of the Earth's atmosphere. Stratospheric ozone protects us from UV radiation, while tropospheric ozone is quite harmful. My question is it possible to move harmful tropospheric ozone into the stratosphere and use it to band-aid the ozone hole? Dean Shimidas.
Yeah, that's a great question. And the answer, I'm sorry to say, is no. The amount of ozone that is in the stratosphere in terms of number of molecules or mass, if you will, is many times larger, orders of magnitude larger than the amount of ozone in the troposphere. So there simply isn't enough ozone to move up there to make a difference. Secondly, ozone, in the concentration of ozone, is tiny, tiny amount, not quite a part per million, less than a part per million, or a tenth of a part per million, which means that out of every 10 million particles in the atmosphere, say at this level, at the ground level, one is ozone. So now what you want to do is you want to find that one ozone molecule out of the 10 million, and find the one over here, and the one over here, and the one over here, separate them out, put them in some sort of a tank, and then move them up. And it's not obvious how you would do that separation. And the other thing is that, as you do that, the ozone could react with something else and it would no longer be ozone, it would be oxygen. So it's a great idea on paper, but it's simply not going to work.
Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Now, Dean Shimidas, not everybody is a congressman or policy wonk, so obviously at some point these issues around climate change intersect in daily life. So talk that through for yourself. What are things you do or reflections you have day to day about climate change and small contributions that individuals can make?
Yeah, individuals can make contributions, and sometimes people get upset because when we talk about these contributions, they're so small, and it takes away from the focus of getting, for example, a significant climate bill there. I think that personal contributions are really important. I think it also makes a statement about what we care about to our representatives. And you've all heard many of the obvious things. Drive less, combine your trips so that you don't drive unnecessarily, don't drive aggressively, keep your car tuned, inflate your tires, buy compact fluorescent light bulbs, or simply more efficient light bulbs. And there are some efficient light bulbs that are not compact fluorescent light bulbs, but you can find them. Turn out the lights, and so on and so forth. One of the things that amazed me when I looked at this is that probably one of the biggest impacts that we all have, at least Americans have, on the climate is the food we eat. Farming is incredibly energy intensive, and particularly energy intensive and climate impacting is the production of meat. And if we all ate less meat, it would be a significant impact, really significant impact on the climate. And the reason for that is that to basically produce a kilogram of protein, a kilogram of calories, I should say a kilocalorie of protein from a cow or a pig requires something on the order of 5 to 7 kilocalories of grains. The vast majority of the nutrients that we feed our livestock and nitrogen and so forth is just, if you pardon the expression, pissed away. And so it's a very, very inefficient thing to do. Additionally, for cows emit a very, very potent global warming gas, methane, from both ends, and so it makes it even worse. So just cutting down our consumption of meat. Many of you, I'm sure, out there are vegetarians. I congratulate you. I unfortunately am not a vegetarian, but I'm trying. And what each of us can do who are not vegetarians is simply eat less meat. Go 1 day a week or 2 days a week without eating meat. It really makes a big difference.
Now, in terms of how people hear about environmental issues and how they're framed up, oftentimes they are addressed in terms of worst case scenarios, global warming, droughts, extinct species, and so on. Is this right? Is the news mostly dire, or are there places to go for good news?
Well, that's a good question. And I think that, the concern that I have and many of my colleagues have is the trajectory. The trajectory is not encouraging in terms of climate, in terms of biodiversity, in terms of forests, rainforests and the like. But there's still a lot of great aspects to the world and to the environment. And I would say, you want to learn about that, just go outside. I know right here in Durham, it's a beautiful day. It's a beautiful day, and that's the good news.
Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. We've got a question here that comes from Camille, and Camille asks, Professor Chamides, can you talk about how to better engage marginalized communities of color in the discussion around climate change?
Wow, that's a great question. That's a great question and an important question. The evidence is that climate change is going to impact all of us, but it's going to especially impact minorities, economically disadvantaged people. A great example of that was the Katrina event in New Orleans. Devastating, catastrophic event that affected everybody in New Orleans. But the people who really, really suffered were the poor. Many of them people of color. And so I think that's where you start. I think you have to explain to people that this is an issue that's extremely important for them and their family. They are going to be disproportionately impacted, and therefore they need to make sure that this issue is addressed.
Very good. Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. We have a Twitter question here that's come in from the NC Office of EE, and the question is, any suggestion on ways educators can help relate climate science to the public?
Climate science to the public. Educators can do that. Well, first of all, I would say that the most important part of that is through education. There is just an enormous amount of misinformation about issues like climate change. And I would encourage educators to get the scientific information from reputable sites like the National Academy of Sciences, and make sure that information is given to your students. I think there needs to be an opportunity for discussion, and I think probably in most classrooms you're going to find people who don't agree with that science. But I think you simply counter by saying, well, this is what the National Academy says, or what have you, and I think you'll have a big impact on that. I think there's also, you can have a variety of different kinds of projects for your students that end up going back into the home that also can make a difference.
Very good, Dean Chamides.
Let me just say one other thing, and that is that so I'm an educator at the university level, and so one of the things that I do in terms of trying to educate the public or bring issues to the public is this. I have a blog and a variety of other things that I do. I go around the community and talk. So I think educators should do that as well. I also think there's a great opportunity for K through 12 educators to do really important stuff. I and my colleagues are always there to help out K through 12 educators, but we're not K through 12 educators, and so I hesitate to tell those educators how to do their job. I need to have them tell me how I can help them do their job.
Viewers can join this Duke Office Hours conversation in 3 ways: by emailing live@duke.edu, visiting the Duke University Facebook page, or using the Twitter tag Duke Live. Dean Chamides, we've been talking about education, and obviously you've dedicated your career to environmental studies. How do you explain that to someone outside the field? Why do you personally choose this field and this pursuit?
Because I'm weird? I don't know. So let me tell you, I can tell you my trajectory, my path. So I started out as a scientist. I was a physicist, and I spent, hours and hours and hours playing with equations to try to figure out how particles would move through a vacuum or would move through an electric field and so on and so forth. And I discovered one day when I was a graduate student that I could apply those same equations to what happens in the outdoors. Apply those equations to how a cloud forms, to the light going through the atmosphere, the sunlight and the colors that appear and so on. And I just found it incredibly interesting and exciting, because I love the outdoors, that when I go outdoors, not only can I appreciate it from that aesthetic level, but I can also appreciate it from the scientific level and say, I understand what's going on. So I spent decades of my life as a scientist to try to understand that stuff. And at some point, as I began to approach my elder years, I found myself being dissatisfied with that. I became more concerned about, as I said, the trajectory that the world was going on relative to the environment. I became concerned for the future of my children and concerned for the future of my grandchildren. And I felt that given my knowledge and my understanding, that I could use that to make a difference. And so I transformed from someone who's simply worrying about the little equations and trying to understand how things work to applying that knowledge to trying to make a difference, to trying to make a better future. And so that's why I'm here.
Thank you, Dean Chamides. Thank you for holding these office hours. Any concluding exhortations, remarks, reflections on Waxman-Markey, climate change, a sort of a goodbye for us here?
Well, sure. That we live again in a democratic country, and participation is really, really important. And if you care about the climate, if you would like to see the United States have a significant climate policy, you should let your representatives know that that's the case. That's a very, very significant thing that you can do.
The conversation continues online. Email live@duke.edu, visit the Duke University Facebook page, or use the Twitter tag Duke Live. Next week's Office Hours is with Professor Janan Reed discussing Muslims in America since 9/11. To learn more about Duke, visit duke.edu.